deep inside hostile territory, where every radar blip spells potential doom. A single F-16 peels off from the main flight, charging forward alone. Its mission? Suicide or a desperate flight? Neither. It's intentionally making itself the brightest target on enemy scopes. That jet is on an incredibly perilous assignment, taunting the predators hidden on the ground below, luring lethal air defense systems into revealing themselves, locking onto them, all for the chance to silence them with anti-radiation missiles, or at minimum, compel them to shut down, paving a safe path for the main strike force. This is the deadly, high-stakes chess match called Wild Weasel. It's a dance requiring not only exceptional bravery, but also the ideal instrument. No heavy behemoth, but a nimble champion, swift as lightning, and incredibly agile. Agile enough to waltz along the razor's edge of survival. An instrument like the F-16 Fighting Falcon. This is the tale of the Fighting Falcon, designed for air superiority, yet mastering the art of confronting threats from below. Join us as we trace its path from a bold idea to a worldwide symbol in today's video. Wild Weasel in action. F-16 Seed Operations. Project Wild Weasel, a United States Air Force program during the Vietnam War, was aimed at developing specialized tactics and equipment to counter the increasing threat from North Vietnamese surface-to-air missiles. The name Wild Weasel evokes the image of a small, agile, intelligent, yet very daring animal, tasked with hunting dangerous venomous snakes. Desert Storm, 1991. The skies over Iraq were no place for the faint of heart. Below lay Saddam Hussein's dense air defense network, bristling with various radars and surface-to-air missiles, ready to engage any coalition aircraft that dared to penetrate. To achieve victory, the coalition needed more than just offensive firepower. They needed the Wild Weasels, courageous pilots tasked with the suppression of enemy air defenses mission. And among those heroes, an agile and versatile warrior emerged, the F-16 Fighting Falcon. Although the seasoned F-4G Phantom II remained the workhorse, hundreds of F-16s were also entrusted with this dance with death. Their mission? It sounded insane, living up to the unofficial Wild Weasel motto, "You gotta be shitting me," reportedly exclaimed by pilots upon first learning the mission's nature. Deliberately fly into harm's way, acting as bait to provoke enemy radar emissions. As soon as enemy radar locked onto the F-16, the aircraft's warning receivers would shriek. This was the signal the pilot awaited. An AGM-88 high-speed anti-radiation missile launched from the wing, automatically homing in on the emitting radar source. The objective, destroy the radar site, or at minimum, frighten the crew into shutting it down, thereby creating a valuable silent corridor for the strike package following behind. But the engagement wasn't over. The instant the high-speed anti-radiation missile launched, the F-16 often became the most targeted aircraft in the sky. Enemy surface-to-air missiles were likely already streaking towards them. Only the F-16's inherent agility, its tremendous G-handling capability, and the pilot's exceptional maneuvering skills, combined with the timely deployment of flares, chaff, and electronic countermeasures, offered a chance to narrowly evade the incoming threat. It was a life-or-death duel of wits and reflexes, decided in moments. And during Desert Storm, the United States deployed 249 F-16s to the Gulf. These fighters flew an incredible 13,340 sorties, more than any other single aircraft type in the conflict. Pilots achieved a remarkable mission-capable rate of 95%, which was 5% higher than their normal peacetime rate. The largest single F-16 mission occurred on January 19, 1991. The notorious Package Q strike against Baghdad. This involved 56 F-16s from the 388th and 401st Tactical Fighter Wings. F-4G Wild Weasels and F-15C Eagles provided escort and top cover. The pilots encountered intense anti-aircraft artillery, surface-to-air missiles, and adverse weather conditions. Despite this, many successfully struck their targets. An account from one pilot, recorded in Vipers in the Storm, conveyed the ferocity. The flak was thicker than soup. If he got shot down, so be it. He was not going to miss that time. Throughout the campaign, the F-16, partnered with the F-4G, formed a highly effective suppression of enemy air defenses duo, executing thousands of missions. Flying ahead of the main strike packages, they cleaned or suppressed Iraqi radar and surface-to-air missile threats, significantly contributing to the coalition's achievement of air supremacy, reducing aircraft losses. and solidifying the F-16's legendary status in this demanding role. The spark of rebellion. The F-16 Fighting Falcon's story started with tough lessons learned in Southeast Asian skies. This revolutionary aircraft came from a crisis in American fighter design, and would later become one of the most successful combat planes ever built. American fighter jets faced unexpected challenges against North Vietnamese aircraft that revealed fatal flaws in widespread design philosophy. United States planners believed dogfighting was obsolete in the 1950s and early 1960s. They focused on nuclear delivery and interception missions. This mistake would get pricey. American F-4 Phantoms didn't deal very well with turning battles against agile MiGs because they lacked guns. Pilots struggled in close-range fights, which forced the United States Air Force to add gun pods to F-4Ds. The F-4Es with built-in guns finally solved this problem in November 1968. The United States Air Force achieved half of its aerial victories with guns in North Vietnam during 1972, not missiles as predicted. The statistics painted a grim picture. Fighting from a defensive position significantly increased the risk of loss. Air Force losses reached 65% when aircraft fought from defensive positions. The overall exchange ratio against MiGs was just 36-1. The Navy performed better with 68-1 compared to the Air Force's 4-1. These numbers showed fighters needed quick maneuverability to avoid defensive positions. A group of maverick thinkers emerged from this combat experience to challenge military aviation wisdom. Colonel John Boyd used his Korean War experience and fighter tactics instruction to develop the energy maneuverability theory with mathematician Thomas Christie. Their revolutionary approach showed how fighters performed in combat by focusing on fast transients, quick changes in speed, altitude, and direction. Boyd gathered innovators called the Fighter Mafia by the late 1960s. This controversial group included defense analysts and pilots who promoted fighter designs different from Air Force leadership's preferences. They believed that aircraft should be lightweight with high thrust-to-weight ratios. Extra weight hurts maneuverability badly. Not a pound for air-to-ground should guide design. Multi-role capability hurts specialized designs. The Fighter Mafia gained support from reform-minded Deputy Secretary of Defense David Packard. They secured $149,000 in 1969 by cleverly suggesting the Navy was developing a small, high-performance aircraft. The money funded the study to confirm the integration of advanced energy maneuverability theory with trade-off analysis. Northrop and General Dynamics split this funding to design aircraft based on Boyd's energy maneuverability theory: small, low drag, lightweight fighters without bomb racks. The Air Force launched the Lightweight Fighter Program on January 6, 1972. They wanted a 20,000-pound class fighter that excelled at speeds between Mach 0.6 and altitudes of 30,000 to 40,000 feet, where most future air combat would happen. The Air Force picked General Dynamics and Northrop from 5 companies to build prototypes. They got contracts worth $9 million and $8 million on January 13, 1972, to make the YF-16 and YF-17. General Dynamics engineers, led by Robert H. Widmer, created the YF-16. It rolled out on December 13, 1973. The first flight happened on February 2, 1974, at Edwards Air Force Base, California. The YF-16 flew 330 sorties totaling 417 hours during testing. It beat its competitor in acceleration, climb rates, endurance, and turn rates. The YF-16 brought new ideas: a blended wing body for better lift and control, fly-by-wire controls instead of heavier hydraulic systems, a 30-degree reclined ejection seat, a side-mounted control stick, a head-up display, and a bubble canopy for great visibility. It used the same Pratt & Whitney F-100 engine as the F-15, which saved money. Secretary of the Air Force John McLucas named the YF-16 the winner on January 13, 1975. The final F-16 added multi-mission capabilities to meet broader Air Force needs. The F-16 Fighting Falcon became one of history's most versatile and successful combat aircraft, even though it moved away from the Fighter Mafia's original vision. Design breakthroughs that set the F-16 apart. The F-16's place in aviation history stems from state-of-the-art technologies. These technologies set new standards for fighter aircraft design worldwide. The General Dynamics F-16 Fighting Falcon brought groundbreaking features that reshaped the scene of aerial combat and influenced fighter design for decades. The F-16 pioneered full fly-by-wire control system with no mechanical backup in military aviation. This system first took flight in the F-16 prototype in 1974. Electronic sensors replaced traditional mechanical connections between the pilot's controls and aircraft surfaces. These sensors sent inputs to hydraulic actuators through computer interpretation. The system stood out because it enabled relaxed static stability. The F-16 became the first production fighter aircraft designed to be slightly aerodynamically unstable. This unusual approach brought remarkable benefits. An unstable aircraft moves more responsively than a stable one. One engineer put it simply, "Stability and maneuverability tend to oppose each other in an airplane." The quadruplex fly-by-wire flight control system watches the aircraft's attitude constantly. It compares pilot inputs and adjusts control surfaces many times each second. Engineers could focus on maneuverability without compromising safety. The result was a fighter that executed fast transients, quick changes in speed, altitude, and direction, better than anything before it. The F-16's bubble canopy gives pilots a clear 360-degree view. This advantage becomes crucial in dogfights where looking behind can mean survival. Pilots can even see their own tail, a feature no other fighter matches. The cockpit's design puts pilots in a 30-degree reclined position. This smart design increases G-tolerance by reducing the distance between heart and brain. Pilots stay conscious during extreme maneuvers, giving them an edge in close-range combat. The cockpit's layout shows brilliant human factors engineering. Critical controls sit within easy reach, and the head-up display shows key flight information right in the pilot's line of sight. This user-friendly design reduces workload during combat, letting pilots focus on tactics rather than managing the aircraft. The F-16's responsive controls and agility create what psychologists call a flow state. Pilots become completely immersed as action and awareness blend together. This creates a flying experience that exceeds basic transportation or weapons delivery. Pilots who move to newer, more advanced aircraft often miss the pure joy of flying the F-16. One pilot put it best, "The F-35 is more capable, but the F-16 is more fun to fly." And this emotional connection explains why pilots worldwide still consider their F-16 cockpit time the highlight of their careers, even after 4 decades. The F-16 engine and performance capabilities. The F-16 Fighting Falcon's remarkable performance comes from its engine options. These engines went through continuous development to boost the fighter's combat effectiveness. The aircraft's propulsion systems have helped it stay dominant through several generations of aerial warfare. Pratt & Whitney's F-100 engine started the F-16's power story. This engine was first developed for the F-15 Eagle. The original F-16 models employed the F-100 PW200, which was a modified version of the F-15's F-100 PW100. It produced 23,130 pounds of thrust. These early engines had problems with compressor stalls and rollbacks, dangerous sudden drops to idle power. Reliability issues ended up triggering what became known as the Great Engine War in the early 1980s. The Air Force began a mission to reduce costs and improve performance through the alternate fighter engine competition. This contest between Pratt & Whitney's F-100 and General Electric's new F-110 engine led to substantial improvements in both engine families. Pratt & Whitney developed the F-100 PW220 with a digital electronic engine control unit that worked much better. Many of these engines later received upgrades to the standard, which cut unscheduled engine removals by 35%. General Electric's F-110 GE100 delivered 4,000 pounds more thrust than the F-100 PW200. The F-16 CD Block 30s became the first to use this engine. They featured a modified inlet called the Modular Common Inlet Duct, or Big Mouth, to handle the F-110's greater airflow needs. Both manufacturers created even more powerful variants through the improved performance engine program by the early 1990s. The F-110 GE129 produced 29,500 pounds of thrust, and the F-100 PW229 delivered 29,160 pounds of thrust. The F-110 GE132 stands as the most powerful F-16 engine today. It generates 32 to 500 pounds of thrust and powers the United Arab Emirates Block 60 aircraft. The F-16's exceptional thrust-to-weight ratio revolutionized air combat tactics. A ratio greater than 1 lets the fighter maintain vertical acceleration. Pilots can climb faster and keep energy during dogfights. One F-16 pilot shared his experience after flying against F-18 Hornets. They could climb 3,000 feet above the F-18, then bunt over to put him in the HUD for a gunshot. Powerful engines combined with the aircraft's lightweight create this performance edge. The F-16 handles up to 9 Gs with full internal fuel, better than other fighter aircraft of its time. Pilots can execute extreme maneuvers that would damage many competing designs. Block 7072 variants keep this advantage today. They have a structural life of 12,000 hours, 50% longer than previous F-16 aircraft. Most air forces can use these planes for about 40 years without major structural repairs. Modern standards still rate the F-16's performance as impressive. The fighter reaches speeds of Mach 2 at altitude. It can travel over 2,002 miles on ferry missions, which gives it great operational flexibility. The F-16's combat radius surpasses potential threat fighter aircraft. It flies more than 500 miles on air-to-surface missions, delivers weapons accurately, fights enemy aircraft, and returns safely. The F-16's maneuverability sets it apart. It pioneered 9G maneuvers as the first fighter built for this capability. This feature, along with its fly-by-wire system and relaxed static stability, creates an extremely agile platform that outmaneuvers many larger fighters. Engine choice affects the aircraft's performance characteristics. Pratt & Whitney engines work better at altitude and speed with higher exhaust gas velocity. General Electric engines excel in mass flow, which helps during takeoff with heavy loads. This flexibility has kept the F-16 competitive for decades. The F-16's influence on future fighter aircraft. The F-16 Fighting Falcon's lasting impact goes beyond its success in operations. This remarkable aircraft changed how designers would think about fighter planes for generations. America's top fifth-generation fighters drew heavily from the F-16's breakthrough technologies. The F-22 Raptor uses the F-16's side-stick controller and reclined seat setup. These features help pilots control the jet better during high-G maneuvers. The F-22 and F-35 Lightning II both use advanced versions of the F-16's fly-by-wire system with much more computing power. The F-16's bubble canopy started a revolution in cockpit visibility that shaped all future fighter designs. The F-35 took this concept further with its distributed aperture system, which gives pilots unmatched awareness of their surroundings. Without doubt, the F-16's biggest contribution was showing that relaxed static stability worked safely in production aircraft. This became key to the F-22's extreme maneuverability and the F-35's control systems. On top of that, the F-16's digital flight controls laid the groundwork for the F-35's complex integrated avionics. Before the F-16, military planners favored heavy, complex multi-role platforms for air combat. The F-16's success in battle quickly made them think over this approach. They saw that smaller, more agile fighters could handle multiple missions effectively. The F-16's combat record with Israeli forces, especially during the 1982 Lebanon War, proved that maneuverability and pilot visibility gave decisive advantages in air combat. These features soon became must-have requirements for fighter designs worldwide. The F-16's groundbreaking digital systems introduced the idea of continuous upgrades through software improvements. Modern fighter programs now see this as standard practice. The F-35 represents the peak of this approach, using regular software block upgrades to improve capabilities without changing hardware. This development method has become the lifeblood of modern military aviation. What the F-16 means to America. The F-16 fighter jet represents American identity beyond its technical prowess and battle record. Since its 1974 debut, the Fighting Falcon has shaped American air power and defense strategy. The F-16 Fighting Falcon displays American aviation innovation that revolutionized combat aircraft. The jet makes up around 40% of the United States Air Force fighter fleet. Its durability is due to its great design and frequent updating. In 2023, United States Air Force pilots flew over 147,000 hours in these aircraft, proving its importance. The Air Force Thunderbirds fly the F-16. Millions of Americans watch this American aeronautical spectacle. These exhibitions combine technical prowess into national pride and establish the aircraft's status as an American technological icon. A military specialist calls it an almost utterly perfect Swiss Army knife. The F-16's impact on air warfare doctrine extends beyond its actions. The multi-role fighter became the future combat aircraft standard. Desert Storm initially demonstrated this adaptability, changing American fighter aircraft design. The F-16 shaped modern air combat. Sixth-generation fighter projects still consider its adaptability, precision, and intuitive design philosophy. Operational persistence makes the F-16 memorable. It is crucial to American air defense doctrine after over 50 years. Some variations may fly until 2070. This unprecedented service life includes the Cold War, global war on terror, and current security threats. Military leaders call it America's best pound-for-pound fighter. By constantly innovating, the F-16 has become an emblem of American air power. 50 years after its first flight, the Fighting Falcon continues to soar, a testament to the enduring power of focused design, adaptability, and raw performance. It stands as a powerful symbol of American aerospace ingenuity and remains a vital component of global air defense. The F-16 Fighting Falcon has more than earned its legendary status, a true icon forged in innovation, proven in combat, and still defining the edge of the envelope. Do you like this plane? If you like it, please leave a comment below and like the video. Thanks for watching.